Welcome to Intro to Statistics Part 1. In this video, we'll be concentrating on a set of data that represents the length of a manufactured item. To the left, we have data that I've organized from smallest up top to largest on bottom, using a filter. You'll need to do this if you're calculating out these values by hand. We have a column for the sample number and a column for the length of the object. To the right, we have a graph with a y-axis of the length and x-axis is the sample number. This is all arranged so that as the sample number increases, the length also increases. I have gone through and used Excel to calculate out the mean or average, mode, median, first and third quartile, 90th percentile, and standard deviation. I'll be walking through how to calculate each of these values by hand. So now, let's go over how to find the average. The formula for the average is the sum of all the terms, which in this case is the sum of all the lengths divided by the count, which is the population or sample size of 30 in this case. The Excel formula is equals average the range of cells in your data. We get an average amount for this data of 183.014. This is the typical value for the data. I have placed an arrow on the data and a line on the graph to indicate its location for your reference. To go over a simpler example, here's a 3-sample example. We take the sum of the values of the 3 samples, then divide by the number of samples, which is 3, and get the displayed answer. Next, we'll be finding the mode, or most often displayed. To find this, you look at the data and count out how many times a value repeats, and find the value that repeats the most. In this case, we have 4 times where 182.76 comes up, so this is the most often displayed in this data set. The Excel formula is equals mode, then the data range. On to finding the median. This is the number that half the data is less and half the data is greater. If you take the number of samples plus 1 and divide by 2, you get the place of the median. In this case, the place is 15.5, which is between 2 numbers. Because the data is ordered smallest to largest, this falls between the 15th entry and the 16th entry. So if we do this by hand, we would take the average of these two numbers. We get a median of 183.055. The Excel formula is equals median of the range of data. Let's move on to the first quartile, where a quarter of the data is less and 3/4 of the data is greater. I want to lead with there are 4 or more methods which you can find the quartiles. Be careful to use the one your teacher or professor wants you to use. This is the method I was taught. We take the sample size n, which in this case is 30, and add 1 and divide by 4 to get the place. In this case, with a sample size of 30, we get a place of 7.75. This falls between 2 points which are identical, so the average of these two numbers are the same as the two numbers' values, which is 182.76. So 182.76 is the first quartile. The Excel formula is equals quartile, then the range of the data, then a 1 for the first quartile. The third quartile is where 3/4 of the data is less and 1/4 of the data is above. The third quartile can be found by taking 3 times n plus 1 divided by 4, or 0.75 times n plus 1 to get the place. The place once again falls between 2 values at a 23.25 place. So if we're calculating this out by hand, I'd be taking the average of the two values. The Excel formula is equals quartile, the range of the data, and a 3 for the third quartile. Excel interpolates or does a weighted value and came up with a value of 183.3. But once again, you could just take the average of the two values and most professors or teachers would be happy with that. On to the 90th percentile, or where 90% of the data is less and 10% is greater. We follow a similar process and take 0.9 times n plus 1 to get the place, which the place falls at 27.9, which is between two numbers once again. So if I was doing this by hand, I'd once again take the average of these two values, but Excel interpolates or does a weighted value and gets 183.419. The Excel formula is equals percentile.exe, then the range of the data, then the percentile, which is 0.9. The range can be found by taking the max value and subtracting the minimum value. So because the data has been organized from least to greatest, we take the 30th value minus the first value and get 0.96 units for our range. This is depicted on the graph. As you can see, we have a 0.96 distance from the max value to the minimum value. To finish off this video, let's talk about the standard deviation. So we first need to discuss population versus sample. If you are analyzing every object you are drawing a conclusion about, you are using the population formula for standard deviation. If you are analyzing a sample of the population you are drawing a conclusion about, you are using the sample formula for standard deviation. The formula for the standard deviation of a population is the square root of the sum of the difference of each value and the population mean squared divided by the size of the population, or n. The standard deviation for a sample of a population is basically the same formula, the only difference being it is divided by the number of observations minus 1. I've listed an example with 3 samples for your reference just so you can check to make sure you are using the formula correctly. So now you're probably thinking, what exactly is the standard deviation? It basically indicates the amount of variation or dispersion in a set of data, or how close the data is to the mean or average. The lower the standard deviation, the closer the values are to the mean or average. The higher the standard deviation, the further away the values are from the mean or average. This video came as a result of a poll. Be sure to like, share, and subscribe to see more content like this. The next 4 videos will all be about statistics. Then following that, I'll do 2 videos on optics just to make everyone who voted happy. Thank you so much for everyone who voted, and thank you for watching.